Spaceflight is always risky. We call it rocket science for a reason. It is difficult, it is complicated, but it's doable. I've spent 6 years of my life on this project, and I hope to spend at least as many more on it, working on the data. So it will work. WISE is the Wide Field Infrared Survey Explorer, and it's a new NASA space telescope that will orbit the Earth and survey the entire sky in infrared. Our eyes see visible light, and infrared is like that light, except the wavelength is longer. Anything that's hotter than absolute zero emits lots of infrared light, and in fact, room temperature objects emit very brightly in infrared. So, for example, right now I'm pouring out infrared, which you can see with this special camera. WISE is not the first all-sky infrared survey. In 1983, the infrared astronomical satellite known as IRAS was launched. Now, IRAS mapped the entire sky in infrared light, but it had only 62 pixels. With WISE, we'll have 4 million infrared pixels that we can use.
This is the RP3 high bay. High bay, just the big room that can fit big equipment. And we are doing a focus test on WISE. Go! What we're doing on a focus test is we're adjusting the focus of our collimator over here. It's like you do with any camera. You just adjust the lens, you move it in and out to change the focus. But of course, WISE is in space. You can't go adjust it out there, and a sub-thousandth of an inch variation can change where your focus is. Go! The computer that controls WISE is way over there. So in order to tell them to start collecting data, I simply have to yell, go! You want WISE to be focused at infinity. It's looking at stars after all. And what we're trying to do is make that spot you see on the screen as small as possible. When the spot is as small as possible, that's our best focus. Go! It's 0.6.
0.6.
Yeah. Oh, good.
Okay.
That's about it there.
We're in focus, and next time we get to measure this, we'll be in orbit. The universe is kind of like a globe. And if you think of yourself as looking at the globe from the inside, you can map out every section of the sky. So WISE is going to observe everything in the universe that's further away from the sun than the Earth is. And so just starting with the closest objects, those will be asteroids. And then further out in the outer parts of the solar system, there's a region that's called the Oort cloud. And if there are significantly sized planets like Neptune-sized or even Jupiter-sized, WISE will find those. Beyond our solar system, we get into the nearby stars, and there's a whole population of failed stars that we expect to find called brown dwarfs, some of which might be closer than any stars we know about. And then moving on beyond that, leaving our galaxy entirely behind, we're able to study all of the nearby galaxies. Going out still further, we get to clusters of galaxies. And then the most distant object that we have thought a lot about are the ultraluminous infrared galaxies, and those are most of the way back to the Big Bang. But even beyond those distances, it's possible that WISE will find yet further objects. And so we'll probably find things that we haven't thought of, and that's the most exciting of all, but I can't tell you what it is.
One of the great things about doing an all-sky survey is that there really is something for everyone. Personally, I'm interested in looking for asteroids, particularly near-Earth objects. I'd like to see how many there are and what sizes, how many are dark, how many are bright, and that will give us a better understanding of the population of potentially hazardous asteroids out there. One of the other projects I'm very interested in is seeing about this nearest star to the sun business. There's a better than 50% chance that our sun actually has a nearest neighbor that's closer than Proxima Centauri, and it's quite likely that this is going to be an ultra-cool brown dwarf.
What I really hope to find out from the WISE dataset is how galaxies form. If we go way back to the Big Bang, the universe was very, very smooth, very, very homogeneous, and there were these little lumps in this sort of sea of plasma that was the universe. And they grew into galaxies and then stars and planets and people. And so we have the ability to detect galaxies out far, far back in time, 10 billion, 12 billion light years away. So we can look back in time and see how these lumps developed and grew into the universe that we see around us today. It's an amazing experience to have worked on something for so long and to have it come along so quickly. And in some ways, it almost seems like an old friend is starting to leave. And I realized a few weeks ago that I'll probably never see WISE again. I was hoping to get another look at it, but I guess not, and I hope not actually, because if I do see it again, that'll mean something has gone wrong.
We are about 15 minutes from launch of the WISE mission, and we're just about 3 miles away from the launch site right here, which you can see in the background. And that's our Delta II rocket. We've just come out of the 20-minute hold, and it's just a little bit longer now.
14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have it. Searching for stars and galaxies never seen before.
Wow. I'm really happy. That's how I feel. Now it's time to get to work. That was the fun part. Well, actually, the fun part is yet to come when we get the first images and the first data.